A very good morning to all of you. This is Jonan Altaf from International Islamic University, Malaysia. And today I'll be speaking on the research topic non invasive stress detection based on discrete wavelet transform and machine learning algorithms. This will be the contents of this presentation. We have the introduction, methodology, followed by results, conclusion, and some references. Beginning with the introduction of stress, it is the pressure or burden that people face during day-to-day activities. And allostosis is how your body responds to stress. So basically, stress is your body's response to anything that requires attention or action. Everyone responds differently to the stressful situations, sometimes knowingly and sometimes unknowingly. If you think that stress might be affecting you, there are few things you can watch for. First is the psychological signs, such as difficulty in concentration and anxiety. There can be emotional signs as well, such as being angry, irritated, or frustrated. Some physical signs include high blood pressure, changes in weight, or even the frequent colds, which you might experience. And the behavioral signs, such as not having enough time for the things you enjoy, or even relying on drugs or alcohol to cope up. Let's look at some of the statistics. The figure on the top left shows that stress is indeed the biggest threat to workplace health, with 70% of the total representatives believing so. There is another figure on the right that talks about Malaysia's healthiest workplace, and even as such a workplace, about 53% of Malaysians have at least one dimension of work-related stress. And there's this survey, we have a survey from the Ministry of Health among the Malaysian teens that show that 1 in 10 teens are stressed due to one or the other reason, which is indeed worrisome. So here's the catch. If we know about the stress existence, then we are in a somewhat better situation. And if we don't know, then we are definitely supposed to know before it causes further irreparable damage. And this work is one such effort that helps in determining the stress with a very high accuracy. The methodology of this research begins with capturing the data using a Rakib smartwatch, as can be seen in the picture. This is the data acquisition phase, which is further followed by the pre-processing and feature extraction, for which we used MATLAB R 2020 version of the MATLAB. The classification based on the features extracted is the last step of the methodology, where many different machine learning classification techniques are used to test for accuracies. Here we used VECA to apply machine learning concepts. We'll be discussing each step of the methodology in the coming slides. In the data acquisition phase, data acquisition was carried on using a Rakib smartwatch, which has a feature that allows one to record the ECG data for 2 minutes. The image on the left is from the Rakib application, and the corresponding raw data is extracted from Favor IoT database using the Postman app, as shown in the figure 2 at the center. One would need a developer ID along with the API key to access and extract the data from their database. And the figure on the right is from the MATLAB plot of the same ECG signal. ECG signals were recorded and while inducing stress as well as making the participants relax while listening to music. At the pre-processing stage, the data extracted was accompanied by some issues such as the baseline drift, and the data also had a very certain high frequencies which did not contain much useful information. So the step 1 was the data detrending. The ECG signal shown in the figure was somewhat deviated from the baseline after a certain time interval. And by using a simple MATLAB function detrend on the original ECG signal, What we achieved was a symmetric ECG signal along the baseline. The step two of the pre-processing was the data denoising. In this step, the noise associated with the ECG signals was removed using an efficient band pass filtering technique called discrete wavelet transform. DWT was able to segregate the coefficients into four layers as shown in the figure. At this stage, we reached a conclusion that only layers 3 and 4 should be used for further processing, and the layers 1 and 2 should be discarded. The main reason was to remove very high and very low frequency components from the ECG signal, as not much information can be obtained from such components. In the feature extraction, this study, 8 features were extracted from ECG signals after the pre-processing phase of applying DWT was completed. The features extracted from both stressed as well as relaxed state signals are mentioned in this table. Features were extracted in both time domain analysis as well as frequency domain analysis of the ECG signals. From as far as the classification is concerned, we first begin with the unsupervised learning. Unsupervised learning came into picture as the data was not labeled, and we applied the clustering techniques to label our data. Figure shown here illustrates the unsupervised learning and the output obtained by applying the simple k-means clustering technique, where the two classes, stress and no stress, form two separate clusters. And there is a clear distinguished boundary between the two. This helped us in labeling our data that we were able to proceed with the application of the machine learning classification algorithms. And this comes in the category of supervised learning, as we already know which ECG signal is stressed and which is not. In order to check for the accuracies, we applied as many as 7 machine learning classification algorithms to determine the best case scenario. The results have been produced under a 10-fold cross-validation scenario. In the results section, first table, this represents the centroid values obtained using the simple k-means clustering of the different features that were extracted from the ECG signals, and this table is an important manifestation of the behavior or trend of features from no stress state to a stress state. And thus the data in the table also helps in determining the features of high interest and the features that could be simply ignored because of their irrelevance in determining the stress. And one more important observation about the heartbeats per minute feature is that though the centroid value of no stress scenario is around 82, but there are instances when the value reaches 100 but is still in no stress condition, and the same observation holds true for heartbeats per minute value of stress state. And the table 2 shows the results of 7 different machine learning classifiers used to find the best case scenario for the labeled ECG data, and which was obtained post clustering. Taking the limited size of the data into consideration, all the results have been produced under 10 cross validation scenario. Apart from accuracies, we have also mentioned few performance parameters for the respective algorithms like the F major, kappa statistic, and the ROC area. It is evident from the table that naive Bayes is the best performer among the 7 classifiers tested for ECG classification, whereas random tree is the worst performer. Here is the comparison table of our work with the other works, and accuracy of 96.67% using a naive Bayes is definitely an achievement, and we do consider that this procedure has this procedure of using the DWT at the pre-processing stage has helped us in achieving such a high accuracy. In conclusion, I would like to say that by this research, we identified and extracted features from ECG signals recorded using Rakib smartwatch, and the ECG signals could be successfully classified into stress and no stress levels using machine learning classifiers. The proposed EWT filtering at the pre-processing stage had a positive impact on the results, and this system was near to real-time stress detection system. Our future goal will be to classify the levels of stress as low stress, medium stress, and high stress. And through this research, we would like to acknowledge the support given by the Ministry of Higher Education Malaysia through FRGS scheme. And I would also like to thank my principal invigilator and principal supervisor, Madam Noorjana Ibrahim, for her support for this project. Some of her references, and that's all from me. Thank you.